We had this problem of when we put in through a correlation, we got back out sort of this flipped thing, all right? And if you remember, here's the equation of correlation. We have this kernel H, and we sum over it, going from minus k to plus k, multiplying it times our image. And what that did was it caused us to end up with that flipped result, all right? The right way of thinking about this is that when an impulse comes in and it hits the filter, what comes back out is sort of this reverse signal. So the right way of thinking about the operator is there's something called convolution. And when we do convolution, that's what we actually mean when we say we're going to apply this filter or this kernel. And what convolution does is it flips both the left, right, and the up, down direction. You could have either flipped the kernel or flipped the access to the pixels. It doesn't matter. You would get the same value. And so that flipping gives you what's referred to as convolution. So by the way, if I was using a Gaussian or a box filter, how will the outputs be different for correlation and convolution? That is, what happens if I flip my Gaussian? Answer, nothing. Okay? For a circularly symmetric or for a symmetric filter, whether I do convolution or correlation doesn't matter. It is going to matter to us in the next lecture, the one after that, when we take derivatives in one direction or the other, and that's when you have to be careful. But if you have a symmetric filter, it doesn't matter. So this can be illustrated nicely in the following way. So here we have the equation for the convolution operator, and we're going to illustrate it like this. All right, so here we have our filter, and there's this little asterisk up here, and the asterisk is to show you sort of what the top right-hand corner is. When we do correlation, we just pick that up and then we sort of slide it around. When we do convolution, what we do is we rotate the thing, and because it essentially flips it left, right, and up, down, right? You see that the little asterisk is now down here in the bottom left-hand corner, okay? And then, thank you, Kristen, we zoom that all over the image, and that gives you your output. So that's our convolution operator. Again, the difference between correlation and convolution only matters if you have an asymmetric filter, but now you know the difference. Like I say, convolution is actually sort of the physics of what's going on when you put an impulse through this response.